Right now, as you're listening to this, you are sitting in a room made entirely of baryonic matter.
Yeah, literally everything around you.
Right. You are made of it. The
Mm.
device you're listening on is made of it. The sun outside, the earth, coal, uranium, it is all baryonic matter.
Every single piece of the visible universe.
Exactly. And for the last century or so, whenever humanity dreams about the ultimate endgame for our energy needs, we always point up at those stars.
We do. We talk about nuclear fusion.
Right, bottling star power. We've always just assumed that once we master fusion, we've basically won the energy game forever.
It is the holy grail, of our current technological paradigm. It's clean, it's virtually limitless.
They could power planetary grids, interstellar ships.
Yeah, exactly. I mean, if you look at human history, fusion is just the logical conclusion to an energy curve that started when early humans first burned wood.
It's all just extracting energy from matter.
Exactly.
But, and this is the core of our deep dive into the source material today, when you look at the raw cosmological data, when you actually account for the universe, that endgame looks, well, laughably short-sighted.
It really does. It's a fundamental flaw in how we view the future.
Because all that baryonic matter, everything you have ever seen, touched, or burned for fuel, that only accounts for roughly 5% of the total mass energy content of the universe.
We are a rounding error, just a tiny cosmic anomaly.
5%.
Right. 95% of reality is completely invisible to us. It's what we call the dark sector. Dark matter and, more importantly for us today, dark energy.
Okay, let's unpack this. Because if we are betting our entire civilizational future on us extracting energy from that 5%, we are basically fighting over crumbs.
While a massive infinite banquet is just sitting right there.
Exactly. Why would we limit ourselves to baryonic crumbs when the other 95% is just waiting to be used?
And that realization is the paradigm shift we're exploring today. The mission of this deep dive is to map out a transition that honestly sounds like pure science fiction.
But it's not.
No, it's increasingly grounded in cutting-edge physics. We're looking at the monumental leap from a civilization that burns matter to one that harvests the vacuum of space itself.
Specifically dark energy, which makes up, 68 to 70% of the universe.
Right around there, yeah. And we're going to see how it can function as a literal self-replenishing vacuum battery.
What blew my mind, going through all this research, is that these aren't just thought experiments anymore. We're talking about actual engineering framework.
Blueprints, essentially.
Yeah, and what's fascinating here is the timing. We're building this discussion on the groundbreaking March 2025 findings from DSI, the Dark Energy Spectroscopic Instrument.
Those findings completely recontextualized the cosmos. They showed us that the vacuum isn't just empty space, it's an active dynamic medium.
So here's the roadmap for you today. We're going to start with the greatest mathematical mismatch in physics history, the mystery of why empty space holds so much hidden power.
The vacuum catastrophe.
Right. From there, we'll get into that 2025 DESI revelation, which changes dark energy from a dead constant into something that's actually alive.
Evolving, yeah.
Then the fun part, the engineering. How do you physically build machines to harvest the expansion of the universe?
We'll look at the mechanical physics of tethering entire galaxies.
Which is wild. And then we'll shrink down to the quantum level to see how information can literally teleport energy out of nothingness.
And finally, what this means for a Kardashev Type 3 or 4e civilization.
Because when you master the vacuum, you don't just build a better power plant. You become the architect of reality itself.
So to really grasp how a civilization could harvest the vacuum, we first need to understand the sheer, mind-boggling scale of the energy hidden in empty space.
Let's start with the concept of nothing, the energy of nothing. When I picture a vacuum, I picture a completely empty box in deep space. You pump out all the air, block the light, remove every hydrogen atom. In classical physics, that box is empty. Zero energy.
But if you look at it through quantum field theory, QFT, that box is anything but empty.
It's actually full.
Very full. In QFT, the universe isn't made of isolated particles. It's made of underlying fields that permeate all space and time.
So like an electromagnetic field, an electron field?
Exactly. Fields for quarks, all of it. What we perceive as a physical particle is really just a localized vibration and excitation in its field.
Like a wave moving across an ocean. The particle is the wave, but the field is the ocean itself.
That's a great analogy. Now, Quantum mechanics has this foundational rule called the Heisenberg uncertainty principle.
Right, the one about not knowing position and momentum at the same time.
Yes, but it also applies to energy and time. It basically states that you cannot have a field with exactly zero energy. Even in its lowest possible state, its ground state, a quantum field is constantly fluctuating.
So it's jittery. It just can't
Uh,
sit perfectly still.
It's practically boiling. Because of these fluctuations, virtual particles are constantly popping into existence.
It's not out of nowhere.
Well, they borrow a tiny amount of energy from the universe and then annihilate each other a fraction of a millisecond later to pay it back.
Wow.
This creates a baseline level of energy everywhere, even in the darkest void. We call it zero-point energy.
Okay, so the empty box contains a boiling soup of virtual particles. I can visualize that. But where things go completely off the rails is when physicists try to calculate exactly how much energy is in that soup.
Yeah, this is where the math gets, well, problematic.
Walk us through it.
When you take standard quantum electrodynamics and you try to sum up the zero-point energies of all these fields, you have to integrate over all possible frequency modes.
All the way up to the Planck scale, right?
Exactly, the fundamental limit of physics. And when you run that calculation, the number the math spits out is staggering.
How staggering.
It predicts a vacuum energy density of around 10 to the 113th joules per cubic meter.
10 to the 113th. That is a 1 followed by 113 zeros.
It's so cosmically large, it loses all meaning.
I mean, my brain can't even process that.
No human brain can. It's vastly more energy than is contained in all the stars, galaxies, and supernovas combined.
Just in 1 cubic meter of empty space.
Yes. And here's the kicker. Einstein's general relativity tells us that energy and mass are the same thing. They both create gravity.
Right. E equals mc squared.
So if the vacuum actually held 10 to the 113th joules of active gravitating energy per cubic meter, the gravitational effect would be apocalyptic.
Like how apocalyptic?
The universe as we know it could never have existed. The sheer gravitational weight would have caused the universe to violently curl up into a microscopic singularity instantly after the Big Bang.
Just crushed immediately.
Or, depending on pressure dynamics, it could have expanded so violently that no structures, no stars, no planets could ever form. Space would rip itself apart before a single star ignited.
But obviously, we are here. You and I are sitting here in baryonic bodies talking. The universe exists.
Really?
So if the quantum math says the vacuum should be infinitely heavy, but astronomical reality says it isn't, how do we measure what's actually out there?
We look at the cosmos. We observe the accelerated expansion of the universe driven by dark energy and calculate its actual density.
And what's the real number?
Roughly 6 times 10 to the negative 10 joules per cubic meter.
10 to the negative 10. So
Exactly.
0.000000006 joules.
Exactly. Which creates a discrepancy of 120 orders of magnitude between the theoretical prediction and the observed reality.
A factor of 10 to the 120th power.
It's known as the vacuum catastrophe, or the cosmological constant discrepancy. It is widely considered the worst, most embarrassing prediction in the entire history of physics.
To make that visual for you listening, it's like looking at the math and expecting a raging ocean of raw energy that could boil the Milky Way in a second. But when you build a telescope and look, you find a single, microscopic drop of water.
The theoretical ocean versus the observed drop. It tells us our two greatest frameworks, quantum mechanics and general relativity, are fundamentally incompatible regarding the vacuum.
But let me look at this from an engineering standpoint. If I'm trying to build a civilization that runs on vacuum energy, I don't care about the math error. I care about the observed reality.
Right. The 10 to the negative 10.
Yeah, and that is vanishingly small. If it's just a single drop of water spread evenly across the cosmos, how could any technology extract it? It sounds way too dilute to be usable fuel.
That's the intuitive block every engineer hits. We are conditioned to extract energy from high-density gradients, concentrated power.
Lump of coal, uranium rod.
Exactly. The vacuum looks useless because it's perfectly smooth and incredibly dilute. But the discrepancy implies we're missing the underlying mechanics.
Meaning the math predicting the giant ocean might not be wrong.
Many advanced models suggest the colossal prediction is actually correct. The energy is there. But it represents a hidden potential suppressed by unknown physical mechanisms.
Like a perfect mathematical cancellation.
Or a hidden symmetry we haven't discovered yet.
So the raging ocean of energy is out there, but it's locked beneath an impenetrable sheet of ice.
Yes. And the tiny amount of dark energy we actually observe pushing galaxies apart is just a microscopic leak in that ice.
Wow. Okay, so if an advanced civilization can identify the catalysts to break that symmetry, to unlock even an infinitesimal fraction of that compressed ocean, they wouldn't be dealing with dilute energy at all.
Not at all. They'd tap into power outputs that render stellar fusion completely obsolete.
But to unlock that ice, you have to understand what you're dealing with. For decades, physics told us dark energy was a static, unchanging property of space.
The cosmological constant, lambda.
Right. And if it's perfectly static, it's thermodynamically useless. You can't extract energy from a flat baseline. It's like trying to turn a water wheel in a perfectly still pond.
Exactly. You need a gradient, a flow from high to low energy. The standard model assumed dark energy was just constant vacuum energy.
Which brings us to the absolute game changer, the March 2025 DSI breakthrough. This is where we learn the pond isn't still. Dark energy is alive.
The DSI collaboration released an analysis combining data from baryon acoustic oscillations, the cosmic microwave background, and supernovae, and it sent shockwaves through the community.
Let's explain how they measured this, because the engineering of DSI is mind-blowing. It's a telescope in Arizona with 5,000 robotic fiber optic eyes.
Tiny robots that position themselves to a fraction of a millimeter to target millions of galaxies.
And they were looking for BO baryon acoustic oscillations. What exactly are those?
Picture the universe shortly after the Big Bang. It wasn't stars and galaxies. It was a blisteringly hot, dense soup of particles, a plasma.
Photons, electrons, baryons.
Right, protons and neutrons. In this soup, there was a constant tug of war. Gravity pulling matter inward and radiation pushing it outward.
Gravity pulls in, radiation pushes out. That creates a vibration.
Literal sound waves. Spherical ripples of pressure moving outward through the plasma, like ripples on a pond.
And they traveled for about 380,000 years, right?
Yes. But then the universe expanded and cooled enough for electrons and protons to form neutral hydrogen atoms.
Recombination. Light could finally travel freely.
And when that happened, the radiation pressure instantly vanished. The sound waves lost their driving force and literally froze in place.
Just static shells of denser matter scattered across the cosmos.
Exactly. And because we know the speed of sound in that plasma and how long they traveled, we know their exact physical size.
About 150 megaparsecs across. A standard cosmic ruler.
So we use this ruler to measure the expansion rate of the universe across time.
And when DSI did this, they found that dark energy is not a constant. It's evolving.
They found evidence at a 2.8 to 4.2 sigma level.
Which is huge.
A 3 sigma result means there's roughly a 0.3% chance it's a fluke. It's very strong evidence. It suggests the density of dark energy is slowly decreasing.
It peaked billions of years ago and is now weakening. This destroys the static model.
Completely. We're moving to a framework known as quintessence.
Right, quintessence. Its model is a distinct scalar field, usually called phi.
Yes.
Let's do an ELI 5 on scalar fields. Like, wind is a vector field because it has speed and direction. It blows north. But a scalar field has no direction.
Think of temperature in the room you're in. Every point has a specific temperature value, but temperature doesn't point north or south.
It's just a value assigned to space.
The quintessence field is like that. It permeates the universe. But crucially, it's slowly rolling down a potential energy slope.
Like a heavy boulder rolling down a hill.
Precisely. It has potential energy from its height and kinetic energy from its rolling speed. As it rolls, its equation of state, which we call WV, varies.
So W is shifting, the boulder is moving.
And the DSI data strongly supports a thawing model.
Walk us through what thawing means.
It means the field was frozen at the top of the hill in the early universe due to extreme friction. Only recently has it thawed and begun to roll down.
And as it rolls, it's actively converting potential energy into kinetic energy, releasing it into the cosmic background.
And it exhibits tracker behavior.
Tracker behavior. This is crucial for the engineering part.
It means the field tracks the ambient density of the universe. When matter diluted, quintessence broke away and became dominant.
So it's interactive.
Yeah.
And here's the light bulb moment. If dark energy is thawing, actively releasing massive energy, an advanced civilization doesn't need to conjure energy from nothing.
Right.
They just need to stand at the bottom of the cosmic hill and intercept the boulder.
The universe provides the gradient. You just place a generator in the flow.
But that creates a brutal mechanical problem. We are baryonic matter.
Yeah.
Governed by electromagnetism, we don't interact with the dark sector.
You can't wrap a copper wire around a scalar field.
Exactly. So how do we bridge that gap?
That brings us to gauged quintessence and the concept of the portal. This dominated the 2023 to 2025 symposiums.
Let's break down gauge quintessence. This is the actual schematic for bleeding energy out of the void.
The theory proposes that the dark energy field operates under its own U1 gauge symmetry.
Okay, what does U1 gauge symmetry mean for a layperson?
Think of it as a rule book for how particles interact. In our world, electromagnetism uses U1 symmetry, and the photon is the force carrier that enforces the rules.
So U1 is why magnets stick to the fridge.
Basically, gauged quintessence says the dark sector has its own parallel rulebook, its own dark gauge boson, a dark photon.
But our photons have zero mass. The dark photon has mass, right?
Yes, and because the quintessence field is thawing, the mass of this dark photon is actively changing over cosmic history.
We have invisible dark photons getting heavier as the universe ages. How does an engineer use that to power a toaster?
Through kinetic mixing, this is the portal. The dark sector and our sector aren't perfectly sealed. The dark gauge boson can mathematically mix with the standard photon.
So the dark photon disguises itself as a regular photon.
Or interacts with its field. And as the dark photon gets heavier, it hits mass thresholds. It becomes unstable and wants to decay.
And because of that kinetic mixing, it has a pathway to decay into our world.
Exactly. If it's massive enough, it can spontaneously decay into an electron-positron pair.
An electron and a positron. Charged matter and antimatter. That's tangible, harvestable energy popping into existence.
By manipulating this vector portal, you literally bleed energy from the quintessence field. You funneled these decays to generate a stream of antimatter.
And you capture it in penny traps magnetic bottles.
Right, because antimatter annihilates if it touches normal matter.
So you suspend it in a vacuum, let a positron interact with an electron, and they annihilate with 100% efficiency. Pure energy. E equals mc squared.
Compared to fusion, which converts maybe a fraction of a percent of mass to energy, this is perfect efficiency.
You're routing the engine of cosmic expansion directly into a power grid, using a dark photon as a quantum transformer to step down the metric expansion of the cosmos into raw voltage.
And we are actively searching the sky for these decay signatures right now. Excess positron fluxes or specific gamma ray backgrounds.
Okay, so that's the subatomic level.
Yeah.
But bleeding dark photons requires insane precision. What if a civilization wants to get industrial? Space is physically expanding. Can we just build a giant sail to catch the cosmic wind?
That's macro-scale harvesting, moving from subatomic decay to structures measured in megaparsecs.
Let's talk about Edward Harrison's cosmic winch, the tethered galaxy mechanism. It sounds like bad sci-fi until you look at the math.
The math is just classical physics scaled up to an extreme.
So imagine a Kardashev Type 3 civilization. They deploy megastructures out into deep space, firing incredibly strong tethers, maybe cosmic strings, and attaching them to a distant galaxy.
A galaxy millions of light years away.
Dark energy is driving the metric expansion of space. The physical distance between us and that galaxy is swelling. Space is stretching, pushing the galaxy away.
The Hubble flow. The galaxies aren't moving through space. The space between them isn't fleeting.
So that distant galaxy recedes, pulling the tether taut. The civilization is using an entire galaxy like a massive cosmic draft horse.
Unspooling the tether to spin impossibly huge generators. You extract mechanical work directly from cosmic expansion.
It's the ultimate wind-up toy.
Yeah.
But wait, I have to stop you because there's a glaring flaw here. Dark energy is causing the expansion to accelerate.
Yes.
The further away a galaxy is, the more space there is to expand, so it appears to recede faster. Doesn't that mean eventually the galaxy is pushed away faster than light? What happens to the tether?
Your intuition is spot on. This is the horizon problem. At the Hubble sphere boundary, the recession velocity exceeds the speed of light relative to the observer.
Just to clarify, the galaxy isn't traveling through space faster than light. Space is just expanding that fast.
Correct. Photons from that galaxy can no longer reach us. It crosses the cosmological event horizon.
So what happens to the physical cable?
The math is unforgiving. The tension approaches infinity. It exceeds the strong nuclear force. No material in the universe can withstand it. The tether snaps.
So the giant cosmic winch is fundamentally broken.
Not broken, just limited.
Yeah.
You have to treat galaxies as depletable fuel. You reel them in until they approach the horizon, then you intentionally disconnect.
You just let the galaxy slip into the dark void forever.
And target a new one.
That is deeply melancholy.
Yeah.
A civilization surviving by burning through the visible universe, tossing galaxies into the void just to keep the lights on.
It is a lonely way to harvest energy. But there's a newer macroscale theory from May 2025 that doesn't require snapping tethers.
Right, Mode-Mudasir's framework. Thermodynamic Gradient Cosmology, or TGC.
This strips away the quantum complexity. It models space-time itself as a compressible, dynamic fluid.
Like water or air.
Exactly. In TGC, the universe is a finite bubble of highly pressurized space-time fluid, expanding into an external absolute void of true nothingness.
So the expansion isn't a mysterious scalar field, it's just a simple pressure gradient. Delta P.
Think of a deep-sea submarine. Inside, immense air pressure. Outside, crushing water pressure. If you puncture the hull, fluid violently rushes to equilibrium.
From high pressure to low pressure.
Invert that for the universe. Our universe is a blisteringly hot, high-pressure bubble. The void has zero pressure. The universe is pushed outward purely by this imbalance, trying to equalize.
And this naturally derives acceleration and gravity.
Yes. Acceleration is a thermodynamic response to export entropy. Gravity is localized pressure deficits. Mass displaces the fluid, creating a pressure drop that pulls matter in.
Okay, so how do you harvest a pressurized fluid universe?
You build a universal-scale heat engine. You place infrastructure at the cosmic boundaries between the hot, dense galactic filaments and the cold, expanding voids.
Like a hydroelectric dam, tapping the flow of space-time trying to reach equilibrium.
Exactly. Classical fluid dynamics on a cosmic scale. The expanding voids are the pistons of a universal engine.
It's breathtaking, turning the structure of the universe into a radiator and a turbine.
Yeah.
But let's bring it back down. Microscale. How do human engineers take the first baby steps?
We start with quantum vacuum engineering, vacuumronics. And the gateway drug is the Casimir effect.
Discovered in 1948, right? It physically proves the vacuum isn't empty.
The setup is simple. Two uncharged, highly reflective metal plates placed incredibly close together in a perfect vacuum, nanometers apart.
No static electricity, no gravity.
Right.
But they get pushed together by a mysterious force.
The radiation pressure of the vacuum. Imagine two ships anchored close together in a rough ocean.
Okay.
Only small waves fit between the ships. The massive ocean swells are too big, so there's more wave energy hitting the outside of the hulls than the inside, pushing them together.
The Casimir effect is the same, but with virtual photons.
Yes. The vacuum physically hammers the outside of the plates harder than the inside.
And we've measured this. So by structuring the local vacuum with geometries or metamaterials, we can artificially modify its energy density.
We're already seeing nanoscale vacuum channel transistors that avoid atom lattice scattering, or resonant dielectric spheres extracting RF power from zero-point fluctuations.
Immortal electronics for the Internet of Things, powered endlessly by ambient fluctuations. Sounds like a utopia.
But we had a massive thermodynamic wall. Standard quantum electrodynamics states the vacuum is immutable and non-degradable.
Right. It's the absolute lowest energy state. You can squeeze it with plates, but you can't mine it continuously.
You cannot extract net energy from a ground state without violating the second law of thermodynamics. It would be a perpetual motion machine. The universe offers no free lunches.
But physicists hate a closed door. Is there a loophole? Can we buy the lunch with a different currency?
We can. The currency is information.
Information as a physical currency. This completely challenges reality.
It's quantum energy teleportation, or QET. It relies on the quantum Maxwell's demon.
Let's unpack the demon. 19th century thought experiment.
Maxwell imagined two chambers of gas connected by a tiny door. A demon controls the door. Fast, hot molecules go right. Slow, cold ones go left.
He creates a temperature gradient out of a mixed system. He basically breaks the second law of thermodynamics.
Until Rolf Landauer proved information is physical. The demon has to observe the molecules. Storing and erasing that data in its memory costs energy. The information has a thermodynamic cost.
So how does a quantum demon hack the vacuum?
You utilize pre-existing quantum entanglement between point A and point B. You make a highly specific measurement of vacuum fluctuations at point A.
Which costs energy, right?
Yes, you inject energy at A, destroying the local ground state, but you gain precise information about the vacuum. And because they are entangled, you now know exactly what the vacuum is doing at B.
So you transmit that classical data to an observer at point B.
They receive perfect knowledge of their local vacuum state. With that specific info, they perform a tailored operation to trick the vacuum, extracting energy at point B.
Leaving point B in a lower energy state. But wait, doesn't that violate the ground state rule?
No, because you paid for it with the information you gained by sacrificing energy at point A. The total energy is conserved. You teleported the energy using information.
It's like a cosmic ATM. The vacuum is an ATM with limitless cash, but it won't dispense a dollar until you input the exact, constantly changing cryptographic PIN.
And that PI is the quantum information. In the vacuum age, knowledge literally is power. You must expend information to extract work.
Which means a macro-scale civilization is essentially building a universe-spanning quantum communication network. The power grid and the information grid are the same thing.
You cannot pump the energy without routing the information.
So when a civilization masters all this, macro tethers, micro portals, what do they become?
A Kardashev Type 3 and eventually Type 4.
Type 3 usually implies building Dyson spheres around every star in a galaxy.
But with dark energy, that's incredibly inefficient. Stars are just tiny crumbs. You harvest the volumetric expansion of the immense intergalactic voids instead.
Farming empty space.
But a Type 3 civilization faces the big freeze. The expansion pushes all other galaxies past the event horizon.
The night sky becomes perfectly black.
So Dr. Dan Hooper suggests stellar harvesting. They use Dyson spheres as Shkadov thrusters.
Was a Shkadov thruster.
A Dyson sphere that only partially encloses a star. The asymmetrical radiation pressure acts like a massive rocket engine, propelling the star through space.
They steer billions of stars toward a central hub, hoarding stars to create a gravitational bunker that resists the metric expansion.
It's the ultimate survival mechanism, but to truly conquer the cosmos, you must become a Type 5, universal sovereignty.
They dictate the rules. They manipulate the quintessence potential itself.
Yes. They could prevent the Big Rip, where dark energy overpowers all forces and shreds atoms by locally dampening the scalar field.
Creating a stable buttle of spacetime. And they could use negative pressure for LQB or warp drives.
Surfing across the galaxy. And ultimately, they could recycle vacuum energy into new baryonic matter.
Reversing entropy.
Resetting the entropy of their domain, sparking localized big bangs to keep their pocket of the universe alive eternally.
It means the universe isn't a dying battery. It's a machine waiting for life to take the controls.
It's the ultimate ascension.
So, just to recap this insane journey, we looked past fusion. We looked at the DSI data showing dark energy as a thawing field. We explored gauged quintessence, kinetic mixing portals, macro tethers, fluid spacetime, and information as currency.
But before we wrap up this deep dive into the source material, there's one final thought. Back to the 120 orders of magnitude mismatch.
The ocean versus the drop.
What if that massive number was the potential energy of the vacuum before a cosmic scale state selection collapsed it down to the tiny value we see today?
Like a quantum wave function collapsing upon observation.
Exactly. What if the early universe was in hyper-energetic superposition and some mechanism forced it to collapse into the low-energy stable state?
If that's true, the dark energy driving our universe apart isn't just empty space. It's the stabilized frozen relic of a cosmic calculation.
The lingering output data of the universe computing its own existence.
And if we can read that information, we aren't just harvesting energy. We are learning the underlying source code of reality itself, reading the leftover data of the Big Bang's first thoughts.
We become information processors seamlessly integrated into the cosmological hardware.
That is something profound to think about the next time you look up at the night sky. The empty black space isn't nothing. It's a locked machine, humming with infinite potential, waiting for us to figure out the password. Thank you for joining us on this deep dive into the source material.